I'm going to spend some time here telling you about R. The main advantage is that it's easy to load the packages that are available, but it does give you a lot of flexibility if you want to get dirty with the data. You can actually build your own algorithm without having to use the pre-built routines. And that's pretty useful. Another big advantage of R, it's pretty widely used. A lot of people in a lot of disciplines use R. At some level, most analysts will speak some level of R. Or, if not R itself, something that will sound and look an awful lot like R. I'm going to give you a number of examples to highlight how you can use various R functionalities. How you can use it to manipulate the data. But the introduction I'm giving you is not complete, right? It's just a bit of a flavor of what you can do with R. I'm not even going to claim that this is a showcase for good programming practices. I'm going to start by telling you a little bit about the environment that we are going to use. Here I'm using something called RStudio. There are 4 main windows. There's a console, lower left, and this is where you need to actually run the code. In the top right, you have the environment history connections window. So this is where you will see the variables that have been created, the objects that have been created, and that are still available to you as you write and compile more code. The bottom right is a window where you can find information about the packages that are installed, get some help on a specific topic, plots as well. Whenever you produce a plot, it is going to show up in the bottom right window. In the top left window is the window where you actually write your code. And then whenever you feel you're comfortable with it, you will select a part of the code and compile it, run it. So by writing something here, highlighting it, or even selecting the line and pressing run, it is going to send that code to R, to the console, and run it. So if I try to run this, you're seeing here, this is the piece of code that I had typed in, except, well, when I try to run it, it doesn't compile because that is not an acceptable or valid R command. The very first thing you might want to do is to verify what packages are installed in R. R usually comes installed with its base package. And there's a lot of things you can do in R with the base package, but a lot of the strong functionality comes from functions, routines that are not available in the base version of R. You need to load specific functions. So it's not a bad idea to take a look at the packages that are actually installed on your version of R. You can do so with the following installed packages. Notice here the brackets. So this looks like you can speak to R and say, hey, check which packages are installed, and click run, and that's going to work. And now it's okay. So what's happened here? It went through. There's a bunch of output. Okay, starting to be a bit messy. What this is telling you is that I have a fair number of packages installed on my version of R, and it gives me some information on other things as well. So on its own, I mean, obviously if you just installed your RStudio or your version of R, you might not have a lot of packages that are installed. I have a lot because I've been running it for a while now. So notice installed packages, right? It tells you what's installed. You could also ask it to update the package, because packages get updated on a regular basis. If I look at the package abind here, well, there's a version of abind that existed, perhaps a year ago, and it could be that the developers, the people who work on the abind package, realize, oh, hang on, there's a bit of a bug, let me roll out a new version. Now, unless I specify that I want my packages to be updated, it is not going to update the package. So I could ask it to update the package abind. Let's see what happens if I try to run this. Notice here I'm leaving the cursor halfway through the line. It is going to know that I'm trying to... Alright, so here I get no error message. Like I see here, abind had it built at 3.60. It's my current version. I'm at 3.6.x, and so it did what it had to do and get an error message. You can also say, well, hang on. I'm not interested in either updating or checking if it is installed. I might want you to actually install the package. Let's say that we didn't know that abind was installed. So install.packages. Okay. Contrast that with installed.packages. These aren't the same function. If I run this, it is going to try to install it. Now let's see what I'm getting a little bit of information. It did install it. So even though it was already installed, if I'm asking it to install it, it's going to go to the comprehensive R archive network, CRAN, and find the latest version of the package and install it. Every once in a while, when you run through this, you'll see that it cannot install it for a variety of reasons. Then you need to spend a fair amount of time trying to figure out what might be wrong with the installation. That could happen. Sometimes you've installed a newer version of R or RStudio, say, and the packages weren't built for that version and they haven't yet been updated. And it might take, a while for the package to become available for the version of R that you have. At any rate, you have a way to check what is available to you and what isn't available to you. Now the thing is, we've seen here, like this abind package. It's right here. It is installed, we've seen it, we've updated it to make sure that we had the latest version, and we reinstalled it just to be on the safe side. But until I flat out load it, R isn't aware that abind is there. Abind is hidden or masked from R. And how would you load this function? It's not that complicated. You need to type in the library. But I can also run it without the quotation marks and it still works. Whereas if I try to install a package without the quotation marks, that won't work. Typing in the library abind means that now abind is unmasked. Now you might be wondering, what is this abind that you keep on talking about? If I want to find out what abind does, it's quite straightforward. Question mark, the name of the package, in this case abind, and that will automatically bring up the help file. In this case, this is a package that allows you to combine multi-dimensional arrays. In these help files, you very often get information about description of what it does, the usage, how you would use it, so it tells you what the parameters might be. In order to use it, you get a little description of what each of these arguments would be. For instance, along is one of the arguments. It's optional and tells you the dimension along which to bind the array. Great. If you scroll down a bit, you'll get a bit of information, details. That could be useful for you if you're trying to figure out if a function you want to use does what you want it to do. And then usually most packages or function files have an example or a set of examples showing you how you could actually run things. So you could flat out go here, copy the code. I'm going to put it here. And I'm going to run these first two things. I'll tell you what that does in a second. I've created two objects, X and Y, and you've seen I've created both of them. So by highlighting the two rows here and pressing run, I'm actually getting both lines to be run at the same time. And if I want to do the rest of them, there you go, I can run all of them. And you see I'm getting outputs. Here we're not going to worry about what the outputs might mean, but you can just see that the example that's available in the file can be run directly at the prompt. If we hadn't installed abind as a library and we tried to run this, well, we'd have a problem because this abind function is not loaded, and then you'd get an error message. Notice as this is happening, here I've created two objects X and Y. Well, if I look in my environment window, I am going to see that there's now something called X and something called Y, which is available to me. How do we arrange for the data to be available in the workspace, this global environment window? Well, you can use built-in data sets. So one of the nice things about R is that it has a bunch of built-in data sets that you can use to test your code out. There's a count and a spray variable. Let's say for my first observation, I had a count of 10 and a spray of A. That doesn't give me that much information. I mean, the name tells me something. Presumably, I'm looking at various types of sprays. Spray A, spray B, spray C, D, E, and F. So there seems to be 6 sprays. And a number of, well, count could be number of insects after the spray's been used. That seems to be like a logical understanding of what we're seeing, but that's only, that's based on the name of the data set, and that could be misleading, right? So the best way to figure it out is to try to query the help file. Oh, it doesn't look as though, right, that's because I didn't spell it properly, right? So we think there should be a help file, but in my hastiness to give you the help file, I made a little mistake. And I'd like to think, look, R, you know what I meant. You saw it right here. Why can't you figure out this is what I meant? Well, R can't do that, right? So you have to be very, very careful. And sure enough, now when I run the correct query, I'm going to get a help file. Let's see what happens if we try to run the example that comes with this. I'm not going to talk about what it says. We're just going to take it as a block, and we'd like to be able to run it. It's there as an example. We should be able to run it. Can we? I'm getting something out of it, right? I'm getting tables. You might recognize this as an ANOVA table. We get a second ANOVA table. There's a plot here. We should perhaps be able to see something like a plot. Let's go back to the bottom right window where we have the help file, where there's a plot function. Okay, I'm able to see some plots that are being created by. Now, the reality of it, though, is that you're not really going to want to work with the insect sprays data set. You'd like to be able to work with your own data. Well, there's many different ways to do that. It depends on the format in which your data is presented. Now, typically, especially if you're working with small data sets, you might have it in an Excel spreadsheet or a CSV file, a comma-separated value file. It might show up as a text file, tab delimited file. Thankfully, R is very flexible. If you want to be able to read a CSV file, it'll help you read a CSV file because it has a function read.csv, which basically, if you give me the path name and the file name, a few other bits of information, it will try to upload it for you and put it into an object, a data frame object that R actually knows how to work with. There's a read.table version. Now, another problem that people usually have when they're working with R is that their data is located somewhere, and the R script that they're working with is located in some other location, and it's not obvious how to get the path name for these things. So one of the things you can do is to try to get a better sense of where you are currently located is to use the function getWorkingDirectory. So this function here will tell you what the working directory for your R session is. So right now everything is happening in the users underscore or dash Patrick Wally, which is my Mac folder. But I might be interested in going somewhere else instead. I might want to set the working directory. You go to session in RStudio. You can go to set working directory and you can choose the directory. So I'm going to send it to where I usually leave my stuff. Of course, your own things will be different. By running the session little gimmick here, I see that this is equivalent to setting my working directory to be this new string. And if I try to rerun get working directory, I will see that now my working directory has changed. Whereas it used to be users /Patrick Wally, now it's users /Patrick Wally /Dropbox /courses, /short courses. I'm going to upload a data set which I'm going to call the teaching data set. It's given as a CSV file, and it is in a folder data which is located in my short courses folder called teaching.csv. So I'm using the read.csv functionality. I need to provide it with a path and a file. So data /teaching.csv. It will have a header, which means that the first row in my CSV file is the name of the variables, and I need to specify what the separator will be. Well, it's a comma separated file, so the separator is a comma. So let me run this, see what happens. Okay, so I'm getting something that makes sense. It's accepted it. It has even created a teaching object. I see it in my global environment. Teaching object, 80 observations of 3 variables. Do a little help file query, right? Except now there's no documentation. This is a data set that I've uploaded externally. Unless as part of my CSV file there's also a help file, I'm not getting anything out of this. So how can I get a sense of what's in there? Well, we're going to use the head function. Now I'm not going to specify how many rows I want. So the number of rows you want in head is optional. If you don't tell it how many rows you want, it is going to give you 6 rows. And what I have is 6 observations. I have a group and a grade. And without a help file, I'm just looking at this, it's not clear what this data set is about. For now, I'm going to leave it there. We're going to revisit this data set in future videos. But on its own, you don't know. And I need to warn you against analyzing data sets when you don't know what the data set's about. You are going to make mistakes. Worse, you might come to conclusions that you think are applicable but make no sense because you have misunderstood what the data was supposed to represent. So we have these variables here that we're not happy about. They don't really aren't useful for anything. They were part of an example that we ran without really knowing what we were doing. How can we actually remove them from the workspace? Well, there's a function called rm that would allow us to remove it. So I'm going to start by removing object fm1. So rm for remove, fm1 between brackets, and notice that it's here now, right? We're seeing it right here. Now when I run, it's gone. So it's not available to me anymore. If I try to call it, I see it's not there. I cannot find it because I've removed it from the environment. I can remove potentially more than one variable at a time. I'd like to remove fm2 and opar. Right, so I separate them by a comma. Sure enough, they're gone. You can do other things. You can save your workspace. The function save.image will allow you to take everything which is here and save it. So now if you were to shut down R and then reopen it, these variables would still be available to you. Let's talk about some simple data manipulation. All I've done up to now is to help you load your data, basically. Tell you how you might load your data. What do you think will happen if I run this bit of code? We recognize this little operator here as an assignment operator. So what this is going to do is create a variable x and assign something to it. Be careful, you already have an x in the global environment and the workspace. So by assigning something to x, you will overwrite the current value of x. That's acceptable. I mean, there'd be many times when you want to do that when you write your code. It's just something you need to be on the lookout. So let me press the run button here so we can see what happens. In the workspace, I'm seeing it here, x integer 1, 2, 3. So what this does is that actually it creates a vector, and it does so using a sequence of numbers. So 1:3 basically says go up by 1 from the lower end 1 to the upper end 3 Well, you have 1, 2, 3. Part of the problem here is that if you have a lot of variables, it might not be easy to find the one you've done. You might want to just see if you can display it the way you can display like the head of the teaching data set, for instance, or you've got an ANOVA table here when you did the summary of an object FM2. So one of the ways you can do this is just by calling the object itself, x. So I've assigned something to x, the vector 1, 2, 3. So that line here does the assignment. The second line, if I call x again, now I'm going to see the object 1, 2, 3. This is what x is. And there's a way to combine these things together. It might be annoying to have to repeat the name of the variables, especially if you have like long names of variables. If you put the assignment line between brackets, you're going to get both the assignment and the display simultaneously. So let me do this. Aha, notice the difference? Assigning between brackets does both the assignment, it's still there, and now I also get to see what the output is. Now let me come up with a new assignment, say a vector of 5 objects, 4, 5, 6, 7, 8. Here's the assignment. I've seen that the old y has been rewritten to this new y, and sure enough, 4, 5, 6, 7, 8. I get that. If I want to see it displayed, I'll type in y directly. But you might say, look, I'm not interested in sequential numbers. The reality is that I'm unlikely to see data that will obey the rule of sequences. What if instead I had 2 observations, 12 and minus 9, say? How do I put that in there? Well, this bit of code will do the job. You are going to be assigning a vector to the variable w. It's going to be 12 minus 9. So the first value is 12, the second value is minus 9. And this is done with the help of a very famous R operator, the C operator. So I like to think of it as concatenating objects. And here you have to be careful. C is it has a very short name because we use it so often. We don't want to be typing in like long strings to be able to call the combiner. But if you decide to call a variable C, which you might know, A, B, C, D, E, you might have some issues here because it's conceivable that you will overwrite the combining operator. Okay. There's a few other operators like that. T, which is the transpose of a matrix, you can't call a variable T because there might be some confusion as to what is actually happening. Or you shouldn't at least call it. You can decide to assign things which are not of the same type to the same object. Look at this line here. I'm assigning an array or vector to an object V, and it is going to be a combination of the object W, which I had assigned previously, with the string pamplemousse. What should we expect to see? Well, let's run it and see what happens. So what I'm seeing here is a display which is, as compactly written as we had here, and you're seeing some quotation marks between each of the objects of the array. What's happening is it is trying to coerce a string, pamplemousse, and a numerical vector 12 minus 9 together. R can only do this if everything is of the same type, and the only way that this can be done is if 12 and minus 9 become strings, not numbers anymore. And if I look at the global environment, you will see that x and y were integers, w was a numeric because of the negative value, and v is a character object. 12 and minus 9 are not numerics anymore, they are characters. I'm going to give you your first matrix. Call it U. This is going to be a matrix which will consist of, well, we know what 1 colon 10 should do. It should give us the first 10 integers in sequence. And it's going to put it in a matrix with 5 columns, right? Except I'm going to take the transpose of that, and I'm going to get then a matrix with 5 rows. Let's try it. You see as well the way in which it places the numbers. If we didn't call the T here, if we just looked at matrix of the objects 1 to 10, 5 columns. Let's just run that. Here I'm not assigning anything, so I'll get to see an outcome. It says 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is how it puts objects into a matrix. The transpose, a little t, basically transforms the rows into columns and the columns into rows. We're going to continue with more examples in the next video. Please take the time, take a look at the notebook where more examples are provided and more concepts are discussed.